raise your hand. What might be one model or drawing or plan that you have to show 3 times 4 equals 12? Jake, give me one. An array. All right, Jake, come put up an array. So an array is one type. Underneath where I put array, please. Watch your hand. There you go. What might be another model or way to show 3 times 4 equals 12? Eva. Equal groups. Come on up and show me equal groups. If you don't have an equal groups drawing, which I didn't see many, please stop doing that. Please make sure that you get one down. Can you put it below? Sorry, okay, that's fine. Okay, so she's got 3 groups of 4. Beautiful. Alright, let me have another model or drawing or some kind of way you can solve this problem. Yeah. Peter, give me one more.
Skip counting by twos.
Skip count. Let's not skip count by 2s. What could we skip count though by? Look at our numbers.
3s.
You could skip count by 3s. Come on, let's skip count by 3s. Remember, we always start at what number?
0.
0. Watch your hand. Only the marker can be on it.
Okay.
See what happens when your jacket catches it? So it's a 0, 3, 6, 9, 12. Awesome. Very nicely done. Any other ways you can think of? I can think of at least one more. Ashlyn? Okay. That's going to look very similar to our skip count. Can you think of another one, Ashlyn? Yes, I want you to add them into your notebook if you haven't. There's one more.
Times.
You already gave me times. Times is right here. One more. James, do you know it? You want to give it a try? We learned it when we did skip counting. Well, that's what Ashlyn said. Patterns are going to look very similar to what Peter already did with skip count. Maylee? Repeated addition. That was our last one. We're going to watch Maylee and see what she does for repeated addition. Watch your arms so you don't put it on there. Very good. Very good. Now you could have merged maybe the repeated addition with the skip count. Remember when we first did skip counting, we said a lot of here is plus 3. Remember doing that? Yeah. So we did a lot of kind of combining skip counting and repeated addition. Riley, do you have something else? That's fine. How many plus 4s did she do? Yep, so we just gotta be careful that we make sure we have the correct number of them. You could have done plus 3, and it would have looked like this. Riley, you want to help me do it? Riley, you want to help me do it?
3 plus
So depending on whether I said 3 4s, 1, 2, 3, or I said 4 3s, 1, 2, 3, 4, that would work. Ashley?
I think that's why you read the book 117. Because both of those numbers always add up to 12.
Mm-hmm. Good. Jada? You good? Pretty good? What you need, Peter?
I learned that you could actually like flip around the number and
So here are some of our strategies for models. These are all visual models. We had to draw something out to see it. Okay? Should be your step 3. Remember our step 3, make a plan and solve it? This is what I should see for multiplication. Now you don't have to do all of them. Maybe, Aiden, what's your favorite?
repeat it.
Okay, so Aiden likes repeated addition. So that's the strategy he's going to use the most. Who likes arrays? So maybe that's the strategy you use the most. What about equal groups? That's probably my personal favorite. Doesn't have to be yours. That might be a strategy that you use. So when you get to step 3 on a word problem and you need to make a plan, draw it out, I need to see at least one strategy. Okay? Yes, ma'am.
That's. Can you do repeated addition in different ways?
What do you mean by that?
Like, can you do something other than that to get the same exact problem? Like you don't have to. Like
Well,
you can draw it. As a
we'll look at that later on. Okay? Okay. All right. So I'm giving you this problem. 2 times 7 equals 14. Let's actually think about it. What does this mean? What does that mean? 2 times 7 equals 14. What kind of information are we getting? What are we even doing? Mitchell, what are we doing?
2 groups of 7.
Beautiful. So we know that times, that X, that symbol, means groups of. So we have how many groups? 2. And how many in each group? 7. I want you to write this down in your notebook. Alright, I want you to write this down and leave some space because we're going to talk about what each of those numbers
On the same page.
if you have space. If not, you can turn the page. Okay, so we have the problem 2 times 7 equals 14. And Mitchell did a really nice job of explaining that 2 means that we have 2 groups. Okay? I want you in your notebook to circle the 2 and the 7. Circle the 2 and the 7. Those have a special name. Have you learned that name yet? I don't know if you've learned it in math lab or not. So these 2 numbers have a special name. In a multiplication equation, we would say that these 2 numbers are called factors.
Yeah.
Have you talked about that in math lab?
No.
Well, here you go.
No.
Take this good information and impress Mr. Cassidy with it. Now you know what a factor is. So it's any number that is in our multiplication equation on this side of the equal sign. So I could say 1 times 6. Those would be factors. There's parts two multiplication equations. Alright, so going back to what Mitchell said, he said that 2 was meaning two groups. That factor, that first one, always means the number of groups. You know that. You know that. That first number always means the number of groups. You need to write that down. That first number, that first factor, if we're being mathematically correct, that first factor always means the number of groups. And that fits with what we know. Two groups of
7.
So you already know that 2 means the number of groups. We're just writing it down so that way you don't forget. And then we know of 7, that second factor means the number of objects in each group. So that means the number of objects in each group. In our example, we have 7 something in each group. We don't have really a unit because we don't know what that is, but we know there's 7 of them in each group. Okay, you need to make sure you write these down. I know it's a lot, and I know it's kind of like, well, Miss Miller, duh, I already know this, but when numbers get more complicated, it's important to go back and remember what they mean. So that first factor, you got this down, Peter? Exactly how I have it. The first factor always means number of groups. Second factor always means objects in each group. Don't make me come over there. Have you learned what the word is for when you have the answer to a multiplication sentence? Have you learned that word yet, Matthew?
Yes.
What is it?
Product.
Product. Very good. So our last number is a product. And that product will give you the total number of objects. First, we have number of groups. Second, we have objects in a group. And then lastly, we get to figure out how many objects all together. Okay? Let's pretend that all of my table groups have the same number. Right? How many groups do I have? 1, 2, 3, 4, 5. I have 5 groups. Let's pretend they're even. Let's pretend they're even of 4. We know that that's not real life, but let's pretend. 5 groups. 4 in each group, pretend, would give us the whole number of you, the total number of kids in my room. Some of this I know is kind of like, well, duh, Miss Miller, I already know this. But go ahead and write it down, because it's easy for you now, but eventually the numbers might get a little bigger and a little more tricky, and I want you to know what they mean. Okay? Don't forget 14. Alright, when we come back, I just want to show you what we're getting ready to do. When we come back, we're going to take that same equation, 2 times 7, and we're going to create a story for it. I'm going to switch back. I just want you to know what we're doing next. Okay?